So this is the second video on tangents, but this time we're going to look at solving equations that have tan in them, the tan ratio. And you'll notice for each of these we're solving for the restricted domain. X is just from negative pi to pi, so very similar to what we did with sine and cos. Let's have a look at the first one. So we've got tan x equals -1. So the first thing I'm going to identify, tan, we've got a negative answer. So where is tan negative? It's negative in quadrants 2 and 4. And I'm going to put my little graph here so I can visualize what's going on. So tan is going to be negative in that quadrant and in that quadrant, where this is my basic angle in there and there. So I need to find out what this angle is and what this angle is. So basic angle is our shift tan, or tan to the -1 of 1. So I'm ignoring the negative now. All I needed the negative for was to identify which quadrants. So to end up with 1, when you do opposite over adjacent, this is your pi on 4 triangle, or your 45-degree triangle, where it's 1, 1 and √2. So the angle I must have had so that you get opposite over adjacent, 1 over 1, must have been pi on 4. So the basic angle that we've got, this is pi on 4 in here, and this must be pi on 4 in there. When I write my answer though for x, I need to give it as an angle between negative pi and pi. So if I go in the negative direction, that is this direction around in that direction. So x will be just your negative pi on 4. And the other angle that we've got is when we go around in the positive direction around to pi. So if we're going around to pi in the positive direction, around to negative pi on the negative, they're the two answers that I will have. So to get that second one, I go around to pi but subtract the pi on 4. So my answers are x equals negative pi on 4, or this is 3 pi on 4, 3/4 of pi. Okay, so they're my two answers for part A. In part B, I'll do this one underneath. We've got tan of 2x equals √3. Tan of 2x equals √3. So this is a double angle formula. They have told us originally that it's for x line between pi and negative pi and pi. So we need to make this fit the same angle. So if in that bracket it says 2x here, we need to make this match with 2x. So it means I've got to double everything. So that's what I'm going to solve. So what you could do, if it makes it a little bit easier, instead of calling it 2x, if you want to call it tan theta equals √3, and we're just solving for theta. So my theta is just representing the 2x. So we're just going to solve for theta, and then we can replace it with the 2x. So just looking at this part here, like I did in the previous question, I've got a positive answer. So identify where it's positive. Tan, positive, in quadrants, this time 1 and 3. So on my graph, quadrant 1, quadrant 3, this is my basic angle in here and here. So the basic angle must just be tan to the -1 of √3. Because there's nothing on the denominator, I'm going to write it over 1 so I can more quickly see in the special triangle. So the triangle that has the √3 is this one. That's your 60-30 triangle, or pi on 3, pi on 6. This is 1, 2. So to get √3 over 1 as opposite over adjacent, we're talking about this angle down here. So my basic angle is pi on 3 from that. So I've just worked out that in this diagram, this is pi on 3 in here, and this is pi on 3 away from the axis in there. So we've now found that theta equals, now keep in mind I am solving this bit at the moment, tan theta's √3 And this angle theta lies between negative 2 pi and 2 pi. So my value of theta, the first one's pi on 3. And then, so I've got this angle here, that's pi on 3. I also am going around to this one, and that is going to be pi plus pi on 3. Though it could have also been a negative angle, because it was from back around to negative 2 pi, so it could have been this angle here, and that angle would have been negative pi plus pi on 3. Or the final answer it could have been in the negative direction is all the way back around here, and that angle would have been negative 2 pi plus pi on 3. I'm going to replace theta with 2x, which is what it was originally. Simplify the right hand side. 1 1/3 is 4/3. Negative 1 out of 3 is negative 2 pi on 3. And negative 2 plus 1 is negative 5 pi on 3. And your final answer to get x, everything's got to be divided by 2. So it turns into pi on 6, 4 pi on 6, negative 2 pi on 6, negative 5 pi on 6, and there's a couple of these that simplify a little bit further. 4/6 is 2/3, 2/6 is 1/3 or negative pi on 3, and negative 5 pi on 6. So I have 4 answers in that particular one there. Okay, that's with the double angle. And then finally, let's move that up. I'm going to come back up the top to answer part C so I can see the question. So in part C they're asking us to solve 2 tan 3x equals 0. So first thing I need to do is get rid of that 2, and I can just divide both sides by 2. I'm really solving tan 3x equals 0. So I'll just put a note here. I've divided both sides by 2. So that simplifies down to there. I was, for this one, solving between negative pi and pi in the original question. So negative pi less than or equal to x less than or equal to pi. In this question, it's 3x. So when I do my answers, I've actually got to, when I first do my inverse tan, I've got to solve for these. And let's make it a bit easier like the last one. Let's let theta equal the 3x, because that'll make it easier to solve if we're just solving tan theta equals 0. No special triangles needed for this one. It must just be a unit circle. So to get tan of an angle equaling 0, it must either be this point here or this point here. And the reason is tan is y over x. 0 divided by 1 is 0, and 0 divided by negative, sorry, I've put that around the wrong way. 0 divided by negative 1 is also going to give you 0. So my answers for 3x, which is what theta is, keeping in mind I can go around to negative 3 pi. Looking at this here, my values for 3x from negative 3 pi, so negative 3 pi is going around negative 1, 2, 3. So I can actually have a value of that one. Let's just undo that bit. So 3x equals negative 3 pi, negative 2 pi, negative pi, and then 0, an angle of 0, pi, 2 pi, 3 pi. Just couldn't fit that on the one line. Finally, to finish off, you want x equals not 3x. Divide everything by 3. So I get negative pi, negative 2 pi on 3, negative pi on 3, 0, it's still going to be 0, pi on 3, 2 pi on 3, and 3 pi on 3 is just going to leave you with pi. So your resultant answer, the very final answer, does sit in the restricted domain, which was x had to lie between negative pi and pi. So that is where we ended up. So you've got some questions from Cambridge further down, and these are listed in your booklet. So it's exercise 15K. I wouldn't spend a long time, but at least pick even just one out of each question to try. The suggested ones in the set work from 1 to 4 are just doing A and C of each, even if you just did 1A, 2A, 3A, 4A, just to at least have consolidated those questions.